All right, so we're going to start a unit on something called linear programming. And before we do that, there's some key terminology that we really need to learn about first. And so I want to start this unit by going over some of those things and introducing you to terms you'll see regularly. Okay, so that's our learning target. So this is what I want us to think about first. You have recently opened your own business. What are some things that might be important to you as you're thinking about this? And really, anything that you can think of here, let's brainstorm some things that would be important to you as a business owner. Okay, so over the course of the next couple lessons, we are going to start talking about what is linear programming and why do we use it. So first of all, linear programming is a method of determining the optimal or best solution. And the way that we do that is we determine what our constraints are. This will be a system of inequalities that forms a certain enclosed region. And then the corners of that region are possible maximum and minimum values for a specific situation. And again, that gives us one of those corners will give us the optimal or best solution. All right, so some key things that we want to mention, and I kind of just talked about that, was constraints. These are the first things that are really important. And you've actually already been doing these. These are just inequalities that limit or restrict the solution region. So when you think about constraints, these are restrictions. And these here are examples of our constraints. And in a business, this might be like, let's say you own a pizza shop. This might be the amount of dough you have in storage. This is a constraint because certainly you cannot make more pizzas once you run out of dough. Okay, so that's a constraint. Another constraint might be the amount of employees that you have. Or the amount of pepperoni that you have, or whatever. These are constraints that restrict some of your options in terms of making things, okay? Okay, so you're already actually familiar with this. This is a feasible region. This is your possible solution region formed by your constraints or your inequalities. And in our last unit, we talked about this. We graphed a system of inequalities and we came up with a solution region, the shaded region. This now is, we are going to be calling this the feasible region. Feasible, as you probably already know, means possible. So this is our possible solution region. And that in this case is that spot right here. Here's our constraints that were listed on the left from the previous slide. And I just graphed those. And when I did that, then we ended up with this solution region. So what this means is, given the constraints for your business, all the stuff in the light purple there are possible options for solutions given your specific set of constraints. Okay. All right. Now, next we have something called the objective function, and this is a pretty important piece. This is the function that we're trying to maximize or minimize. This is really what we're trying to make and get the optimal solution, the best solution. Often you will find out this will be a profit equation or a cost equation, something along those lines. And again, notice this is an equation, not an inequality. This is the thing you are trying to maximize or minimize. In this particular case, this P here stands for profit. So profit is equal to 4 times X. So X might be maybe the number of pepperoni pizzas you can make, and you make $4 profit every time you sell a pepperoni pizza. And then Y, let's say, is cheese pizzas. So you make $5 profit for every time you sell a cheese pizza. And so then overall, how much money do you make? And once you know your solution region, you should be able to determine your possible outcomes. And we'll talk more here on this next slide about what's happening. Okay, looks like I duplicated that, so let's go to the next one. All right, so here, a key piece of linear programming is that the vertices, okay? And that is, remember, just the corners of your shape. And in our case, it's going to be the corners of our feasible region. These are the points that you are going to test in your objective function. And that is really how you're going to determine which one is the best, okay? You don't have to, the nice thing about this property is saying that the corners or the vertices will always be the maximum or minimum, is now I don't have to test all those points that are in that purple region. I can just test those 3 points that form the vertices of my feasible region. So this means your optimal or best solution will occur at one of those points, okay? Now, I have a couple of things to do once I graph. Now notice I wrote in here 4.8, 2.4, that's that point. Now I figured that out. When I looked at the graph, I didn't know exactly what that point was because it's very difficult to tell. So I had to go back, and this is where I had to use some of my previous knowledge. I had to take these 2 equations right here, or inequalities, and I solved those because they're in standard form. I used elimination to figure out what that point was. So I found where they crossed, where they intersected, and again using elimination. So you might have to do that on occasion. Sometimes the graph will be pretty easy to tell. You won't have to do this, but this one, not so much. And then these other points are easier. So this point right here is the point 0, 6, and this is 0, 4. Okay, so here are my 3 test points or 3 vertices. So now what I'm going to do is I'm going to test those and find out which one would be the best. So let's just say my first one I'm going to test is 0, 4. And what we're going to do is we're going to test them in this function here. In other words, we're just going to plug in for x and y and see what we get, right? So profit here is going to be equal to 4 times 0 plus 5 times y is 4. Okay, so that would give me a profit of $20. Okay, well, if I do 0, 6, 4 times 0 plus 5 times 6, and this would give me 30. Okay, and then lastly, the point 4.8, 2.4. Oops. Plug that in. Okay, and figure out what I get. So let's see, I would do 4 times 4.8 plus 5 times 2.4. We get 31.2. So that's a little bit better than 0.6, but not much. But so if I was to say which one is the best in terms of giving me the most amount of profit, it would be this. And once we have more context, we could say a little bit more about this, but that would be our optimal solution because it gives us the most profit. So this is how linear programming works, is we will need to, let's go back through here. You're going to take a problem and write the constraints or the inequalities. Okay, this will probably be the most challenging part, is coming up from the word problem that they give you, writing all the constraints. Then you're going to take those constraints and graph them, forming your feasible region. Once you know that, you will need to again pull out the objective function from the word problem and find out what is your objective function. And then Once you know that, you'll take the vertices of your objective function or of your feasible region and plug it into your objective function to figure out which is the best solution. And that is some key terms to linear programming.